Somewhere in the asteroid belt, there's a 100-kilometer-wide rock shaped like nothing astronomers have ever confirmed before. Not two connected heads, like the strange objects we already knew about, but three. And it managed to hide that shape from us for 170 years. The object is called 44 Nysa, first spotted back in 1857 by the German-French astronomer Hermann Goldschmidt. It orbits out in the main asteroid belt, in that wide gap of space between Mars and Jupiter, and it's one of the largest and brightest asteroids ever cataloged there. For most of its history, though, Nysa was really just a point of light. Even the Hubble Space Telescope, for all its power, couldn't resolve much detail about its actual shape. Earlier studies, based on how its brightness flickered as it spun, hinted that it might be elongated, maybe even split into two connected lobes, similar to other contact binary asteroids astronomers had already cataloged, like the one NASA's Lucy mission flew past back in 2025. New observations, published this month, blew that simpler picture apart completely. A team led by Kate Minker at Lowell Observatory in Arizona used two of the most powerful ground-based telescopes on the planet to get a proper look. One was the Large Binocular Telescope on Mount Graham in Arizona. The other was a Very Large Telescope on Mount Paranal in Chile. Both instruments used a technique called adaptive optics, which corrects for the blurring effect of Earth's atmosphere in real time, essentially unblurring the image while it's still being captured. Combined with specialized image processing methods and additional data collected on separate nights, that setup gave the team the sharpest view of Nysa ever recorded. What came back wasn't a simple elongated shape, and it wasn't a clean two-lobed contact binary either. It was something stranger, a highly irregular concave body made up of what appears to be three separate connected sections, joined together by two narrow necks. Astronomers have a word for that kind of pinched-in connection between lobes. They call it a column, plural colli. And Nysa has two of them, one between each pair of lobes. Put together, the whole object measures roughly 113 kilometers by 67 kilometers by 65 kilometers. According to the research team, it's the first object of its kind ever confirmed in the solar system. Not two heads, but three. Two explanations are on the table right now for how something like that actually forms, and the team hasn't picked a winner yet. The one they consider more likely is that Nysa is what's called a contact trinary, three separate asteroid-sized bodies that drifted together over time and gently fused, held in place afterward mostly by their own weak mutual gravity. The alternative is that it's actually one single object the whole way through, just extraordinarily irregular and lumpy, shaped by billions of years of small impacts and structural stress in a way that happens to look like three connected pieces from the outside. Both explanations remain firmly on the table for now, and the team has been careful not to claim one has been definitively proven over the other. There's a detail buried in Nysa's composition that makes this question even more interesting. And it turns us from a story about a weirdly shaped rock into a story about the birth of the solar system itself. Nysa belongs to a rare category of asteroids called E-types, made of a bright iron-free silicate mineral called enstatite. That specific composition links it to an equally rare category of meteorites that occasionally turn up on Earth, called obrites. Material like that is thought to have formed extremely early and under unusually dry, high-temperature conditions during the earliest stages of solar system formation, roughly 4.5 billion years ago. So Nysa isn't just a strangely shaped rock. It may be one of the more direct physical samples we have of conditions from the very beginning of planet formation, just still floating out there in the belt instead of buried on Earth. And then there's a detail almost buried at the bottom of the story that on its own would have been a headline all by itself. Nysa has a moon, one nobody had ever confirmed before this study. It's tiny, only about 1 kilometer across, orbiting Nysa at a distance of roughly 170 kilometers. Finding it wasn't easy. The moon's faint light was almost completely overwhelmed by the brightness of Nysa itself, so the team borrowed a technique normally used in a completely different corner of astronomy: high-contrast imaging. The same general approach scientists use to directly photograph faint exoplanets sitting right next to blindingly bright stars. Because the moon showed up independently in 2 separate observing campaigns, the team could actually track its motion and confirm it really was orbiting Nysa, rather than being some unrelated object that happened to drift through the frame. It's worth being clear and genuinely honest about how carefully the researchers are treating all of this. The findings were posted to the Archive preprint server and submitted to a journal for peer review, and the team's own language throughout the paper stays cautious. They describe Nysa as either a contact trinary or an extremely irregular coherent body, not as a settled, fully resolved case. That kind of caution is normal, and even healthy, for a genuinely new category of object. Nobody had ever confirmed a three-lobed asteroid before, so there's no existing playbook to simply check the new data against. Even so, the implications reach well past this one strange rock. If Nysa really is a contact trinary, it suggests that multiple separate bodies merging together, gently, without shattering each other apart, might be a far more common and far more stable outcome than current models of asteroid formation generally assume. If it turns out to be one single, oddly shaped object instead, that tells a different, but equally interesting story. That asteroids can apparently hold themselves together in far stranger, lumpier configurations than anyone had previously modeled or expected. Either answer quietly rewrites part of the story of how the rocky building blocks of planets first came together, back when the solar system itself was still taking shape. It also matters for reasons that go beyond pure curiosity about the distant past. Knowing the true shape and internal structure of an asteroid isn't just an academic detail. It directly affects how planetary defense scientists would plan a deflection mission if an object like this one ever needed to be nudged off a collision course. A single, solid, well-behaved rock responds to a kinetic impact in fairly predictable ways. A loosely bound cluster of 3 separate bodies, held together mostly by weak gravity, could behave completely differently, potentially fragmenting, wobbling unpredictably, or absorbing an impact in a way current models don't fully account for. Understanding objects like Nysa in detail is part of building a more complete picture of what's actually out there in the belt. Not just how many objects exist, but what they're really made of, and how they're actually put together. For now, confirming which explanation is correct will likely require more observing time, and possibly a closer look than ground-based telescopes, however powerful, can ultimately provide. Kate Minker and her team have described the images as remarkably unusual, a fittingly careful way of describing a result that raises more new questions than it settles. Future observing campaigns, potentially using space-based telescopes capable of even sharper resolution, could help settle definitively whether Nysa is 3 worlds gently fused into one, or one deeply strange world all along. there's a small, almost poetic detail hiding in the name itself. Nysa is drawn from Greek mythology, the name of the mythical valley where the god Dionysus was secretly raised in hiding by nymphs, kept safely out of sight until he was old enough to reveal who he really was. It's hard not to notice the parallel. This asteroid has been sitting in plain view, cataloged and studied for 170 years, and it kept its real shape hidden from us the entire time, right up until the exact moment our instruments finally became sharp enough to see it clearly. Beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel. New episodes on space, physics, and the edges of what we understand, with new content going up every day.